Hey, what's up, guys, and welcome back to another video. And in this video, we are gonna solve, as you can see in the thumbnail, TCS NQT first April morning shift coding questions live. So here are the question, and I personally attended the examination, and I was able to solve both the questions and each question containing 7 test cases. So I was able to solve both the questions. So let us start with the first question. That was the easy one, and the question says. The title of the question was laptop battery and meeting duration. So in this problem, we are given with m minutes of meeting duration and an array of battery levels of an laptop. So we have to find here that how many laptops can be used for the meeting. So the condition is if the battery level of the laptop is greater than equals to the meeting duration, then we have to count the laptops as usable. So let's discuss the input format. So the first line contains an integer n that represent the number of laptops, and the second line contains the n space separated integers that represent the battery levels of the laptop, and the third line contains m, that is the meeting duration. And inside the output format, you just have to print that how many laptops are usable. So if we go through the first simple test case, so n is 5, and here is the given array of 30, 60, 90, 55, and 120, and the muting duration is 60. So we can see that 60, 90, and 120, these laptops, I mean at index 1, at index 2, and at index 4, these are the usable laptops for meetings. So the output is 3. So in TCS NQT, we have to solve from scratch. So we'll be solving in VS Code, and yeah, this is a very easy question. But the thing is, you should be knowing about how to take inputs and how to take outputs and all. So let us code this. So starting with the class solution, I'll be writing a production level code here because for good marks, I'm using object oriented programming here. So I'll be declaring a class solution, and the function solve, this is my template, and I'll be passing self here, and starting with the main function, if name equals to main, so we have to call solution class directly with the solve function. Okay, so we are calling directly the class with the solve function. So let us define the solve function. So here it's given that the first line will contain an integer n. So let us take the input. So n is equals to integer of input of strip. Why strip? Because it removes the leading and the trailing spaces from the array, from the input. And after that, the second line contains space separated n integers representing the battery levels. So levels equals to list of the list of map of integer comma input comma split. So what this function is doing, what we are doing here is we are taking an input array which will take input as a string, and the split function will split the input based on the space, and this map function with will typecast each and every string as input, and this list will wrap up all the inputs inside the list. So these are the levels, and the next line will contain duration, that is a meeting duration. So meeting duration will be a single input array, input dot strip. So this is our input for the given question. Now let us make a one more function that will solve the question. So we'll say count laptops, that will have self and levels and duration. Okay, we can also pass n here, n. Okay, now we'll take a count variable and slice with 0, and for each laptop, feed each level in levels, what we'll do, if level is greater than equals to duration, then we'll increase the count. It is a very easy question. And then return count from here. And inside the output, what we had to print is, we'll take answer is equals to self dot count laptops and levels and duration and end. So this is our the final answer, and we have to print the answer. So this was the exact code I wrote in the TCS NQT exam, and all the test cases were passing. So let me run this program, and we'll test for this test case. Okay, Python count laptop.py. So we'll input 5 here, and then 30, 60, 90, 85, 120. And the next is 60. So we will get answer 3 here, as you can see. So this was our first question. So let us discuss the time complexity. So time complexity will be big O of n, because we are just traversing through all the battery levels and checking for validity. So big O of n, and space complexity was big O of 1, because we are not using any kind of extra space except the count, which is constant. Okay. So this was the first question, and I hope you'll be able to understand this question. And if you are coding in C++ or Java, I'll pin down the solution for C++ and Java in the description. Let us go towards the next question. And the second question says happy and sad state transition. So the problem statement says that in a city, people can be in two emotional states. One is the happy state and one is the sad state. Initially, there are H peoples in the happy state and S people in the sad state. Okay, so there are H peoples and then S peoples. So every day, people change their emotions state according to the following rules. From the happy state, 30% remains happy and 70% remains sad. And from the sad state, 50% remains happy and 50% remains sad. So this was the main given question, and given the initial number of happy customers and sad peoples and the number of days d, determine the number of people in happy and sad states after d days. Okay, so I actually made this question dynamic, just because I made it dynamic because I wanted to show you how we can code it if the question is dynamic in nature. So it's a simple mathematical formula. Let me write the formula here. Actually, initially I was trying recursion initially, but then in the later stage, after 20 minutes of grinding, I got to know the formula is simple. It's saying that for each state, new happy would be previous happy into zero point 0.3. It means only 30% of the people will stay happy, and 50% of sad people will be stay in happy state, and 50% will be sad, as it is written here. And same for the sad state. So the new sad will be 0.7% of the happy and 0.5% of the sad. So this was the main formula for the question, and I was able to derive it within 20 minutes. Previously, I was using recursion, so recursion was not working. And yeah, so let us code this solution as well. So we are gonna take solutions and name class from this previous question. Okay, so we'll write time complexity later words. So here, yeah, it is count laptops. We are removing this, and we'll say uh get what to written here, get peoples get peoples, and cell will be passed here, and number of happy states and number of sad state and number of days. So these are the parameter to be passed. And after that, in the input, first line will contain h, so we'll give h here, and the second line will contain h, so we'll make 3 copies of this, and h, s, and d. So these are the 3 inputs that we'll take. And after that, we call our get distribution. We can say get distribution. Get distribution. Okay, so we'll get happy and sad from here. Happy, comma, sad from here. So we'll pass H, S, and T. And yeah, so this is our function that we called here, and there is one more edge case here, that if if H is actually in the inside the question we were given that uh, we are only given with the H, so initially we had to consider S as 0, so we are removing it from here. I simply modify the question, and D was hard coded with 4, so we had to return the output after 4 iterations. Okay, so we don't need to pass it here. Okay, so if H is less than equal to 0, if there are no people inside happy state and sad state is already 0, then what we'll do, we'll have to print error, and then we have to return from here. And after going inside the get list, there's one more edge case in which I was stuck, and then I was able to figure out that if H equals to 1, then return 0 comma 1, because in the later stage, in the first iteration, 1 will happy and sad state will be distributed as 1 0 and 1 from 1 to 0. So what I'm trying to say is, initially if n is 1, for example, if n equals to 1, if n equals to, then what will happen inside the happy state, we'll have 1, and steady state will be 0 initially. In the first iteration we'll have happy as 0 and sad as 1, but in the second iteration both will assign to values 1. So you can see here we are given with only one people, and in the second iteration we are getting two people. So this is an edge case. So for this you have to return 0 comma 1. That is the answer of the first output. Now let's go towards the main logic for this question. So we'll define happy is equals to H and sad equals to 0 initially. And for I in range for I in range 4 for I in range 4, new happy, I'll copy the formula from here. I wrote it. New happy will be this, and new sad will be this. And after that, you have to reassign your new happy and new sad here. Got it? And after that, just return happy comma sad. So this was the main idea behind it. So we have covered this edge case, and laterwards we also covered this edge case which is returning, and after that you have to print um happy space sad. Got it? So this was our answer. So let us try to run this code, and that is Python happy and sad. And in this we'll give output as 100. Let's see. So the division is C. There's an error. Yeah, I got to know. There's an error. If we do like this now, then our this will give values in float. So we have to round this. We have to round this and this as well. Now this will give us correct value 42 and 58. And in the in the actual question, the given test case was 1000. So let me run that case. Yeah, I was getting the exact same answer, and if I am typing 0, then I'll get error, and if I type 1, then it will be 0 and 1. And this was the question. Let us discuss the time complexity for this question. So what we're doing, we are running a constant loop, and then these are unit operations, constant time operations. So the time complexity for this is constant, and the space complexity is also constant, because we are only taking two variables here, h and s. So this was the solution for the question, and I'll make sure to pin the C++ and Java solution for these two questions. I wrote it in front of you, and I hope you like the solution. So I'll also be attaching this PDF of the questions and the test cases in the description, so you can check out there. So that's it for today's.